Welcome to Answer Factory, where we're talking about every question under the sun. Lately, we're focusing on computer science, and we're going to talk about what is a database index. I hope you enjoy my beautiful ChatGPT generated illustration of a database index. It's like a lot of people sitting there categorizing books and putting them into little cabinets, but it's done with a program. It's incredible. We're going to go into it. Let's talk about it. So when you think about a database, imagine a vast library filled with books. Now, if you needed to find a book on, say, gardening, you wouldn't want to search every shelf and open every book to find it. Instead, you'd use the library's index to quickly locate the section where gardening books are kept. In the digital world, databases use a similar concept called indexes to store and query data efficiently. What are indexes? A database index is a data structure. Okay? It's a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and storage space, which are used to maintain the structure. So, indexes are used to quickly locate data without having to search every single row in a database every time a database table is accessed. Okay, so if there's 1,000 rows and you're doing a query, okay, you're saying give me the row where name is, give me the book where the title is Daddy, I love you. Okay, give me the book titled Daddy, I love you. And I got to look through 1,000 rows of my database. That's going to take 1,000 lookup operations. Okay, so a database index is a data structure, which means by a data structure I mean it's a thing in the memory of the program that runs the database that keeps track of some data. It keeps track of data about what is inside of this table, right? So it says, hey, in general, this is kind of the structure. There's books about this, there's books about this, there's books about this, right? So it's kind of keeping track of, what are all the different pieces of data in there, right? And so, an index can be used to locate data without searching every row in a table. It's going to make it much faster, almost logarithmically faster. And we're going to check out how that works. So how does an index work? Number one, the structure. Most database indexes work using a tree structure, okay? So it's a tree structure which allows you to say, is it this? No. Is it this? No. Is it this? This? Okay, and as we know from computer science, trees are very fast to find things, okay? It's logarithmically fast, okay? That means it's much faster than linear search, okay? So when a query is made, the database uses that index. It searches a tree. Okay, there's several types of indexes: primary indexes, unique indexes, composite index. Everyone is a different particular use case, but they're all the same behind the scenes. They're all a thing in memory that is like basically a tree structure that stores basically a map of what the content looks like, and then you can use that as a quick lookup. Okay. Now there's also the index process, and when data is added, removed, or updated in a table, the database is automatically going to update those indexes. Okay, so this takes time. So if you tell your database, hey, put an index on this column, then every time you modify that table, that index is going to have to get modified. So your database has to manually go in and modify that tree. Okay, that takes time, it takes energy, that's a process, and that's why indexes aren't free. Sure, they make your database faster, but they're not free, okay? It does significantly speed up query time, so you should definitely use an index. Look, is this simple, okay? If you're a programmer and you're using a database, right, and you're making My First Pony app, what you should do is if you're doing a query which says, like my table's called books and there's a title column, and I'm doing a query, find all books with title equals X, right? You should definitely have an index on the title column of your books. No questions asked, okay? So if you learn nothing from this video except that, just learn that. If you're doing a query for something, it damn well needs an index. Otherwise, it will not scale, okay? There's a big difference between log X and X. So if you have 1,000,000 rows, okay, let me calculate. What's log 1,000,000? I should know this. What's log 1,000,000? 6. Okay, so at 1,000,000 rows, we're talking about, instead of doing 1,000,000 lookups, doing 6. Like, it's crazy. It's like crazy fast. So like, it's a night and day. If you don't have indexes on your things, then your queries are going to be horrible. Okay, it's going to be a nightmare. So put an index on that. Okay, so let's do some examples. Okay, primary key index. Okay, so a primary key is like your ID column usually in a database, but sometimes it's also like defined as a combination of columns that uniquely identify a row. So you could have a primary key index, okay? And that's usually automatically created. If you create a table in like PostgreSQL, the ID column will automatically have an index. So when you look something up by ID, it'll always be very, very fast, okay? Then there's what's called a unique index, which is basically saying it's a data structure that allows you to look something up, like we're talking about title in the books table, but it also enforces uniqueness, right? So it says there can only be one book of one title, right? So you're adding that extra constraint. That's what a unique index is. A composite index is an index with 2 or more columns. So for instance, if you have title and then subtitle, because you're searching not only by title, but you're also searching by subtitle, or you're searching sometimes by author as well as title, you might have a composite index. Okay, and that's its own video, but basically it makes it even faster to find something by both columns, okay, by the title and the author. And those composite indexes come into their own when you have lots and lots of data and you're doing complex queries with multiple columns in the where clause, right? And then so those are the main types of indexes. And then there's something called a full text index, which is it's another data structure. It's actually not a tree. I believe it's called an inverted tree or something. I forgot. But essentially, it's used for searching for like snippets of text, right? So if you're putting like the actual content of your book into a column on your database, then you could put a full text index on that column, and then you could like search for particular stuff inside of the text of your book, like find a keyword, like your book mentions the word cooking, and someone types cook, and now you can easily search cook is within this particular entry of the book's table, right? So that's where a full text index could come in. And now there's another type of index which not many people used to talk about, but now it's getting big, and that's a vector, right? And so a vector, basically hard to describe. It's kind of like a full text index, except you're running it through something like ChatGPT to understand the text. And so it's like an index on the understanding of a piece of text. So rather than being an index of going through an entire book and all of the content, it's like if you ran the book through ChatGPT and then you asked ChatGPT to like make a summary, like tell me what are the general concepts from the book, and then now you have an index on that. So now if you say, give me books about pets, then even if the keyword pet wasn't in the entry, just because the concept pet was in the entry, now your index is going to successfully query that. And that's called a vector index, right? So we have vectors, we have full text indexes, and then we have normal tree indexes which could be either a unique index, a composite index, which is multiple columns, or just a single column index. Okay, so lots of stuff on indexes. Let's talk about performance. Why do you use an index? Number one, speed, okay? When you have a column indexed, you can easily query by that column. It's a no-brainer. It's actually a requirement if you're writing any sort of code that has any sort of production capabilities. You have to have an index on something if you're querying by it, because you cannot be just running, they're called full table scans, when you search an entire table looking for something. When you have millions of columns, if you do a full table scan, you just wrecked your database. If you push that to production, you'll just DDoS your own database and it'll die. So indexes are required for speed. They're required for efficiency, okay? Trade-offs, okay? So while they speed up read operations, we know that they slow down write operations, because every time you change a column, you now have to, or every time you change like an entry in your database, now it has to manually go in and update all of your index data structures. So you can see there's a trade-off. And then finally, there's memory, right? Because indexes are stored in memory. So you can only have so many indexes before your database runs out of memory. So there's a game here. You know, you can't just query every table by every column and just have a happy life. It doesn't work that way. You have to kind of be smart about what columns am I indexing by on a given table. It's probably not all of them. It's probably one or two columns. And that's called your indexing strategy. And so people can, some systems will automatically suggest database indexes, and they'll do them automatically. I think that's the future. I don't think it really makes sense that people should like be manually kind of figuring out their indexing strategy. But that's kind of the state of the art right now. Is if you're a programmer, you're using a database, you're going to need an index strategy, and you're going to need to figure that out. So just as a well-organized library allows you to find books quickly, database indexes allow rapid data retrieval, making them a cornerstone of efficient database management. And by understanding and implementing the right types of indexes, database administrators and programmers can ensure that their applications are not going to be a dumpster fire and that they're going to work properly in production, okay? And remember, indexes are not free. Although they speed everything up and they make your life great, they also take time and energy and memory to create. So it's a balancing act. So I hope you learned something about how indexes work, you know, the different types of indexes. Remember, you have vectors, full text search, and normal indexes. Yeah, I hope you learned something about practically how you might implement them into your apps.